Okay, so this is Organic 2, 2212, lesson 11. And I'm going to demonstrate with this what I have demonstrated in some of the other videos, and that is how to take a lesson plan and prepare for the material at hand. So I'm going to look first of all at the objectives, every one of these objectives. Number one is name carboxylic acids and acyl chlorides, esters, and amides. So what we're going to do is we're going to go to section 16.1 and 16 to 16.5, and we're going to look at the nomenclature that we've been asked to do there. Every time you approach nomenclature, the very first thing you want to do is you want to be able to name the very simplest, okay? And then you want to name the next simplest, okay? So the simplest organic compound for most of our functional groups begins with meth, right? So we're going to go to the carboxylic acid section in 16.1, and naming, okay, carboxylic acids and acid derivatives. So we find that we go through the steps like we've done before, and with all of our other things, find the longest carbon chain with the principal functional group in it, and write out the number of carbons. And then we find with carboxylic acids we get rid of the E and write oic acid, okay, methanoic acid. And you'll see if you look on page 722 or 723 that there's a common name that goes for methanoic acid, and it is formic acid, okay? So it's one carbon in the longest carbon chain, and that's the functional group for it, right? What about the second one? So again, we're going to do this every time. Name the simplest possible. You've got to consider for every objective what's the simplest possible question that could be asked on a quiz. If you can't get that, then you truly don't get the objective. If you do get that, then yes, we're starting to get somewhere, okay? So then the next thing we do is we name the next simplest. And so the next simplest would be, of course, ethane, right? Get rid of the E, oic acid. All right, that's two carbons. We have another name for that, a common name. What is it? That's one that I'm going to use in class, and whenever I use it or put it on a quiz or exam, I think I'm giving you an easy one, okay? That's an old friend of ours. Okay, what about the next one? Propane. Oic acid. Now I'm going to quit drawing the full Lewis structure for that. I'm just going to draw three carbons, right? 1, 2, 3. Propanoic acid. And the common name for that the textbook gives you is propionic acid. And I'll tell you from my experience, I've never seen that on a quiz or exam. Not at GGC, not in the MCAT, not anywhere. So, you know, you might want to learn that. If you're really concerned about getting all the common names, then yeah, you have to know it. It's in the book. I will tell you that I've never seen it on any quiz or exam at GGC or any place else. The next one, of course, is butane. Butanoic acid. And that is butyric acid. And I'll say the same thing for that one. I've never seen that on a quiz or exam any place. The next one, I think, gosh, is caproic acid. I don't know, 1, 2, 3, 4, 5, 6. I don't know. No, caproic acid is 6. What's 5? Pentanoic acid? I don't think there's a common name for that. So, all right, there's an illustration of naming. That's objective number 1, naming carboxylic acids. I'm going to give you, so the next thing is acid chlorides or acyl chlorides. I'm going to skip that one because it's something you can look up, but I'm going to go to esters, which I think is a little more difficult. Okay, so for esters, it's a carboxylic acid derivative. Let's draw a pretty simple ester. Okay, and these are named like this, right? 1, 2, 3. That's propane. Okay, and for esters, that's this part right here. Okay, and there's the substituent. We name this propanoate, and then that we have to name as a methoxy. And you might appreciate that it's alkoxy alkane O8. That's sort of the general form for it. Actually, it looks like that. If that's methoxy, that really incorporates that whole darn thing right there, doesn't it? Okay. So that's, in my opinion, the difficult one for objective number 1 is ester. So let me, with this in mind, let me ask you, what is this? That's a question. That's a good question. It's not the very simplest one, right? Again, we're naming the simplest and then the next simplest. It's not the very simplest one, but it's definitely a couple more carbons, and otherwise it's the same thing. Okay, so please be ready to answer that question in a quiz or exam. Alright, that's objective number 1. Objective number 2 is describe the structure of a carboxyl group and their derivatives. Describe the structure. And so, let me just go straight to it. Of course, you're going to be looking in chapter 16.2, chapter 16.3. 16.2 is the structure of carboxylic acids and their derivatives. Let me tell you the main point of this. And it's going to go, so the next objective is physical properties and reactivity. And it comes right straight out of the structure, of course. The structure is trigonoplanar. And you have a partial minus there, a partial positive here, partial minus here. Please don't even memorize this. Please look through and think about that. Don't memorize that. This is something that we got for the first time in Gen Chem. You should step your way through that whole structure right there and see. This, by the way, can all be this can all be in a planar, in the same plane, right? Coplanar 1, 2, 3, because that's a trigonoplanar atom. So these three are automatically in the same plane, right? And that can be rotated into the plane. You should build that. All right, I really strongly recommend you do not put that on a 3x5 card. That's something you have to think about. Okay, that's objective number 2. That's the structure. Now, what physical properties do we see that could come straight from that? Well, we know this is our old friend that we've used as a reference molecule all the time, right? We look at that, and we know that one of the most important structures that we ever consider is a transient dipole-dipole interaction between a hydrogen that's bonded to an electronegative element and another electronegative element, which we call, what do we call that? You got to know that, okay? If you don't know it, pause it, look it up, call me, text me. That's something that's an old friend of ours. Well, do you see a possibility for that here? Absolutely. So let me draw propanoic acid. One, two, three. Okay. So there's 2 molecules of propanoic acid. And we're going to have that same interaction right there. So what do you suppose this would do to the boiling point? That's a BP. What would that do to the boiling point? Relative to, what do you predict the boiling point to that relative to 2 molecules? Well, right, it's the intermolecular forces that dictate the boiling point. Here's a methoxypropionate, and here's propionic acid. Or no, I just said I was never going to see it. It's propanoic acid. Just said you never saw that in a quiz or exam, and you won't. Okay, this is propanoic acid. This is methoxypropionate. What do you suppose the boiling point difference would be between those guys? And those come directly out of this interaction right there. That's a direct consequence of that interaction. Okay? The next objective is physical properties. Oops, that was what I just talked about, boiling point. Okay? That last piece of paper had both the structure and the physical properties. And finally, explain the reactivity of carboxylic acids and their derivatives. Well, it turns out that let me draw a couple of these guys, right? It turns out that the reactivity of this, what's the most, whenever we're talking about reactivity, we're looking both for a nucleophile, an electrophile, right? That's what we're looking for reactivities. What's the charge on an electrophile? You need to know that. Somebody who loves electrons, so it's going to be a plus, right? What's the charge on a nucleophile? It's going to be a minus, and oftentimes that'll be accompanied, a nucleophile will have a lone pair of electrons. So where's the nucleophilic spot in this compound, and where's the electrophilic spot in this compound? Well, there's the partial positive right there, right? And of course there's a partial positive. So in our first lesson of Organic 1, we talked about electron transfer or acid-base reactions. Oops, that's not a partial positive. That might be a partial positive, it's barely, right? That's a carbon. I'm looking at this one. Right? That's the acidic hydrogen. Right? So we might have a proton transfer in terms of reactivity. What kind of reactions are we expecting? By the way, the next lesson is dedicated to the reactions of this thing, okay? So we're really just sort of hinting at the reactivity here at this one. So, yep, definitely. But if you have something that's going to get attacked, it's going to be that carbon right there. All right, and in lesson 12 of Organic 2, we will talk about the